All right, here we go. 4-3. This is another rat. Wouldn't that be a scary scene? Oh, my word. All right, we'll leave that. Okay. Unlike the previous right angle theorem, this right angle theorem does something slightly different. We don't end up with two things being congruent, right? Instead, we end up with two right angles, right? And it says basically if two angles are congruent and supplementary, then they are right angles. All right? So here goes a proof of that, if you will. So we got the diagram, angle 1, angle 2, congruent. You know, looks like they're on a straight line, so we can assume that they are a straight angle. So here we go. Angle 1 is congruent to angle 2. That is given. I'll do the reasons just orally, so hopefully you can pick up on those. Number 2, 1 and 2 are supplementary. We can assume that. Sorry, that's not an assumption. That's just the definition of straight angle. Okay, that it is 180 degrees, and so those two angles have to add up to 180. Number 3, definition of supplementary. Measure of angle 1 plus the measure of angle 2 equals 180, 180. Right? Number 3, got to get that video of those mice out of the way. We know that the measure of angle 1 equals the measure of angle 2, and that is coming from line 1. That is the definition of congruence. Okay? So, line 2. Well, if that's the case, then I can substitute, right? I can put 1 in for 2, right? Or 2 in for 1. In this case, I'll put 1 in for 1, 2. And so then the twice measure of angle 1 has to equal 180. So then by the division property, measure of angle 1 is 90. Okay? And then we know by the definition of right angles that angle 1 is right. I could repeat this process with steps 5 and 8, replacing the angle 1 with angle 2. And I'd get angle 2 is right. So we now know that angle 1 and angle 2 are both right angles. It becomes important in a proof like this that we have right angles. We can see that clearly here in our proof, right? So at some point, I need to get angle 1 and 2 congruent. We can tell that they're supplementary, but the idea is, how do I get them to be congruent? Well, lo and behold, nothing new here. We have to show those two triangles are congruent. So you can kind of surmise that we have the hypotenuses, or in this case, sorry, we have the radiuses that are the same. Yes? We have a midpoint. So sure enough, this is a shared side. So by side, 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 these two triangles are congruent, right? So then we can say angle 1 is congruent to angle 2 by CPCTC. Therefore, angle 1 and angle 2 are right. Again, that's by definition. Sorry, that's by our another rat. All right, and that's, you can write the theorem out, or again, if you just specify a name like another rat, another right angle theorem, that'll be sufficient. And line 10, by definition of perpendicular, if you got two right angles next to each other, they've got to be definition of perpendicular. All right? I'm not going to go through the second proof here. But again, similarly, you got to draw the rhombus. Okay, there's no diagram. Make sure that you draw it out. And a rhombus means all four sides are the same. So that's what they give us in the diagram. And I need to prove that AC and BD are perpendicular. And this is going to be important about next chapter. Okay, I want to show that those are perpendicular lines. So again, to do that, you need to have two lines which are somehow showing these are congruent. Okay, once you get that, then you can say angle 1 is perpendicular. And as soon as you get 1 perpendicular, 2's got to be perpendicular. Okay, a right angle as well. Hopefully that makes sense to you, and good luck in doing the homework.